Hello everyone. Welcome to another edition of online Be Android Meetup. I hope you all are doing fine at home and staying safe. So we are back after a long break of meetups, but we just had our Dev Fest. Hope you have attended that, and there are like multiple tracks for web, mobile, Flutter, everything. And if you have not attended live, then the descriptions of the video recordings are like the links of the video recordings are in description. So you can go and check out those videos after this meetup. And there are there are beginners, intermediate, and advanced level talks done all on the DevFest. And if if anyone is joining new, let me just quickly give introduction to BL Android. So at BL Android, we organize monthly meetups in Bangalore. Usually those meetups are offline where people get together to an office and, and then there are talks and people do networking. But due to this COVID-19, we are arranging all those this online on YouTube, so we can still reach our community members and help them improve their Android knowledge and like introduce them to new technologies and new trends that are coming up in Android. So today we have three amazing talks lined up. So without further ado, let me add Adit to the stream. Hey Adit.
Hey, how are you, man?
Hi, I'm good, good. How are you?
I'm good.
Cool.
Great.
So Adit is one of our regular attendees to the meetups. He would have attended a lot. I guess we met at the meetups, Android meetups itself. And he works at Gojek. He's also given multiple talks into DroidCons and India level DevFests, many talks. And today he is here with us to share amazing insights that they learned, when scaling a large, huge scale app like Gojek. So I'll let Ali talk about more about Gojek and what they do. Let me add your slides. Yeah, that you can continue.
Right. Hey, good evening and welcome to the talk. In this talk, we're going to be talking about something different today. It's not the usual tech talk. So this topic is very close to my heart, especially when you are learning or growing with a large scale team such as Gojek. So the topic today is learning from failures while building, say, something like a large scale application. I'll be sharing some tips and some tricks that we follow at Gojek. Okay. Now, to begin with, for people who don't know me, I'll introduce myself. I'm Adit. I work as a product engineer at Gojek. Gojek is an Indonesian-based company. We primarily are a service-based company, meaning that we provide multiple services. Now, what do you think is Gojek? Gojek is something that is growing exponentially. Like we have multiple services. We have close to about 25 plus services now, spanning across multiple countries. We have a huge growth factor. We like to call it the hockey stick growth. There are a lot of stories and routines and failures that we publish on our Medium. You can definitely go check it out. We are not very shy about talking about our failures. And today, this topic is to kind of show you what we do at Gojek and maybe inspire you, and maybe you can build something similar, right? Now, one important thing of this topic would be to kind of realize the fact that failures are very important. The more we fail, the faster we grow, all right? Right? Now, this is how we learn, right? The hard way, by choosing tough things to do and then try and break it into smaller chunks. Now, you must be wondering why, like, how does Gojek grow so quickly? So we are currently live in 5 countries, right? We are live in Indonesia, Singapore, Vietnam, Philippines, and more coming soon, right? What's happening here is that we have tons of engineers, obviously. Plus, we also have a great mindset. Like we always try to achieve, no matter what the problem statement is, we'll try and break it down and try and see how best we can write. If you realize with Gojek, you launch one feature and there are at least 100 to 1,000 and then to 1,000,000. Like the scale goes very exponentially fast. Now, I have this saying that I really like here. I've not failed. I've just found 10,000 ways that won't work. The reason I like this is because Thomas Edison was famous for never giving up and always had the drive to search for his answers. This was during his time when he was figuring out how to build the electric bulb, right? Similarly, this is how usually when the growth increases, when you have lots of features to build and you have a lot of things going on in your life, at work, that is, your desk would look something like this, right? Where you have your phones, you have like coffee, you have like toys lying around, you have like tens of mouses, half the time hardware failures, half the time MacBook doesn't work, or stuff like that, right? Now, what we're doing here is that we're going to be discussing something really fun today. We're going to be looking at a few things. Well, first one is devote yourself to a growth mindset. You must be wondering, what is a growth mindset? It's basically, very plain English, it would be like embrace more challenges head on. Do not be afraid of taking something new. Maybe learn something new that you've never tried before. Or try and avoid burnout. I'll come to some points and how to avoid these things and how to be persistent in the face of a challenge, right? Also, very important, learn to say no early in your career. What I mean by that is do not accept everything on their face value. If someone says, hey, can you build this in a day? Just say, hey, let me review this. Let me go back on the drawing board and let me try and, resurface with a proper estimate, right? And always choose your battle wisely. So the motto is like learn quick, fail fast, right? Okay, so coming to our Android repo. At Gojek, we have primarily three sides to our engineering team. One is a consumer side, one more is a driver team, which I currently work with, and there's one more called merchant side. So there are three peas in a pod, right? So when I joined Gojek, there was this amazing problem set at the hand where we had lots of features. Like if you realize we have a lot of products, a lot of services that we expose to our consumers across multiple countries. Now, there's obviously going to be a lot of code base, right? As you write, it becomes legacy. Some of it becomes new features that you keep adding. And we literally ship every 3-4 weeks. Like we have a rollout happening every 3 or 4 weeks from the first day of the month, right? Now, we had this challenge where we had lots of modules. So how did we kind of compress it down? Like, how did we get it right? So what we did, one thing was we built a monolith code base, meaning that we have one single repo for the consumer side and same for the driver side. What we have achieved is by taking all of products or all the core functionalities or features and broken it into individual modules. Now, there are a few things that I'm going to be discussing over in this talk. Some of these are, finding the zeros and ones. What was the most important thing? What is black and white? Does this feature stay? Does it not? And so forth. So if you realize this was a major refactoring, we were rebuilding our entire struct from the ground up, right? We did follow something called Yagni. You ain't gonna need it. If you can even come up with 1 or 2 points that points to a certain feature to be live, we'll keep it, and in a certain fashion, right? When you write a code, you could do it better. And this opportunity that came knocking to us was like, hey, we've written this legacy code. Can we improve it now? Do we want to touch it or not, right? If it works, don't break it, right? Now, the next angle was something called as build feature toggles. This has helped us quite a bit. I'll get into details later on. Also, what strategies we used and how did we, if you realize our code base is pretty large, so how do we ensure stability in production? And also a very favorite topic of mine, how to avoid burnout. A lot of people in my peers kind of say that, hey, I love working at X, but there's a moment in time when things just don't go the right way. So we'll take a look at all of these. Starting with our monolith repo. So we have about 150 plus Gradle modules, and these modules are primarily addressed to build either a function or a product or core component. Now, how did we kind of distribute this? So we have divided it based on product. So if you realize we have something called as food delivery, we have like a payment gateway called GoPay, we have ride sharing services, we have a lot of shopping on our app and so forth, right? So we divided all of these modules based on product, and each of these modules can then become more granular and have sub features or sub tasks and so forth. Now, there was this point where we had ensuring stability, right? Where how do we ensure stability? So we have dedicated teams and ownership is per module, right? Oh, sorry, per product module. Now, what happens is that there's a tech lead who manages a group of people, and there are engineers, obviously. Everyone is literally deemed as a product engineer. It doesn't really change at what level you are. Everyone, in some way or the other, is interacting with the code. So what we do is we do a lot of test cases. We do a lot of debates. We do a lot of code roast. Code roast is the term that we kind of really enjoy sharing with our teammates. This is where, let's say that I'm part of a team and we have 5 of us, and 2 of them have played together and built something, and then they want opinion from the other 3. And we can sit in a small 30-minute meeting, discuss what the code is, what was the requirement, and so forth. So we do a lot of those momentary discussions as well. And the last and not least, tooling and productivity. How do we ensure that our tooling works perfectly? Now, we have a lot of problems with our tooling. So a few stats on how we, like what are people doing at Gojek, right? About 70% of our devs work on a single module at a time. Remaining about like 25% work maybe 2, maybe 3 modules at a time. And most of us kind of have our fingers dipped in a lot of things together. So we have like 4 or 5 modules that we are kind of playing around with, right? Now, when I say single commit, we also have few Git strategies that I will be sharing with you. And with that, I have one little statement to make. Just throw your ego out the window, tackle one line at a time. I think this is a motto that we kind of really love and follow extensively at Gojek. Next, we come to our next problem statement. What are the zeros and ones? What is black? What is white? What is green, right? So what we follow is we read our code from bottoms up, meaning that we go to the very granular nitty-gritty of it. It means that we just not only build a particular feature, we also take a hard stance look at there's a design team that comes up with the designs, and then we go over them with our PMs and our designers and even our testing crew, right? QAs and so forth, to see if a particular feature can be mixed with something else or does it stand alone, right? And a bottom-up approach is kind of nice for the learning curve as well. Like you will know the nitty-gritty of it at when production code is pushed. Second, priorities, right? Priorities are like, first we'll build the core product. Like for example, when I say food delivery, right? Food delivery or shopping and all these little product features that we have within our super app. What happens is that there are a lot of things that you can build one time and then reuse it, right? The dry principle. So how do we break it down into stages? So we took the core, put it separate, we built the product module separate, and then we did a bit of tooling on top of it, and we refactor based on this. We also follow a very simple principle: fail fast, grow smarter. So what I mean by that is, like, if you can break your own code before it even reaches to, say, someone like a QA, sorry, let's try and break it with the dev. So we do a lot of a term called dev bug testing. What this means is that we sit with a QA, pair up for like say 15, 20 minutes and show them the basic feature. Maybe you don't have the designs yet, but then, or maybe you don't have, say, something like the backend ready, but we still try and mock our interfaces and see what we can show at least on the UI to the QA, and then the feedback, and try and close the loops and find more edge cases. Few other things that we kind of do is like understand and divide the problem. So if you realize that we have a slightly good, decent number of engineers per product, and what happens is that not everyone works on everything. So we try and divide a problem based on the best criteria available to us. Like if a person is very good at something, we will definitely devote him or her towards that, and so forth. Also, we like to say test and brace for impact, because once it goes live, you should be able to control the stability and, or rather, control the feature from, say, breaking in production. Also, 2 important points: if you don't have a code style in your repo, please do bring it with your team. At Gojek, we have a dedicated code style that only, we use it across all our projects, and similarly with the PR process. PR is basically a merge request where we use, instead of GitHub, we use GitLab, and we have like templates, we have detailed Slack channels and so forth, and we have like a process. If your PR is not reviewed in a day, who's responsible? How does it get informed? So we have built a lot of automations around it as well, so it informs the reviewer as well. Next, we come to something called as Yagni. You ain't going to need it, meaning that we follow a mindset where we don't write something and then try. We also try to avoid breaking it in the future. So the way we do it is that we avoid over-engineering. We build it in the most basic format, or the basic sense of what the product is required for, write a piece of code, and see what else can kind of sit with it, and then push it out the door. Once it is pushed out of the door, we then take a look back, say, in a week, once we start seeing some numbers, say something from an analytical tool. And based on that, then we control some variables and then try and change the aspect. We don't go very hasty about our decisions when it comes to like, hey, let's build this also, let's build that also. We kind of prefer quality over quantity. So we always ship pretty regularly, but then we also push quality code out. Also, just avoid, just in case I need it, that's a very bad attitude. Try and say, hey, is this really needed right now? Can we do it at a later stage? Can we pre-plan it? Can we have a milestone on when this feature can roll out? Like, it's no point of building the entire X feature in one sitting, right? Rather have it in multiple and so forth. Also find a reasonable use case and stick with it. Do not keep rewiring your mind thinking, oh, what will happen when this changes? So we try and avoid those. Next, we use a lot of feature toggles. If for folks who have never used a feature toggle is something that kind of turns off your feature completely. Think of it like a stopgap, or think of it like a short circuit. If for example, you log into your application, if you have a login system, and there is this new design for, like recently Gojek relaunched on the consumer side, we relaunched something called as the Gojek Consumer 4.0 version, where we completely rewired our UI. If you have a chance, please go to Play Store and try it out. We did a lot of fancy animations. We did a lot of fancy things that kind of enlighten the users and give them the product that they most use. So when it came to this, we obviously had to do a lot of A/B testing with the users. If you realize we have millions of users on our code base, so we can't just launch it 100% and be mind-free, right? What this gives us is it gives us an opportunity for some users, like beta users, to try early access. We can turn that feature toggle only for those guys. And obviously, there are things like Fab-based remote config. And internally, we have something called a segmentation service, which we love to utilize in those heavy lifters. A heavy lifter in our case would be like launching a brand new food screen or building a new flow for placing a ride booking. A ride is where you get a motorcycle, come to your point A, and take you to point B. Also, to kind of add to that, it also gives you a nice little kill switch in the nuclear option. If something goes horribly wrong, just kill the damn thing. And you are saved from production issues. Like we have production support and so forth. But if you realize it's not as easy as pushing a code and expecting the people will not use it, we would rather have a kill switch. So if something goes wrong there, you can turn it off. Also, it gives us an option for users to opt in if they choose to stick with the new feature. Or if they feel that it doesn't resonate well with them, they can always move back to the old one and so forth. Also, it really, really helps with the rollouts and kind of helps us sunset some things that are no longer production, or rather should be live in production. So it kind of is very good goals there. A few things that we kind of do when we build features. We do feature flags versus, like we take feature flags over branching. Now, when I say this, what we do is we have a stable develop branch where maximum stability, if possible, we'll try and push it there. We then take a cutoff and say, hey, this is a release candidate. This is where we are going to say, hey, this is where this particular code that is going to be shipped in the next version should be available in this. So we have like release candidates. We then kind of back merge it to master. Master is where there's no active development, but it's all about back merging. Back merge in this case is when you launch a feature, or you launch a particular version, you bring it back to master and then rebase it to your develop. We also try and avoid long-lived branching, because the more long-lived your branches are in your Git strategy, the harder it becomes to kind of correlate with other team members. Like maybe, let's say you're a team of 5, 2 of you are working on some feature and it kind of gets, you are able to make it for the release cut. Now, other 3 who are not participating in a particular release may start writing new code, right? Or may start breaking something that is that needs to be reviewed, or that needs to be like properly vetted and tested, right? Now, if you do a long-lived branch, what will happen is the code that you're kind of merging into will obviously change and it will mutate, right? So avoid doing those moments. Like try and have short-lived branches. Also, you have full control of your lifecycle with toggles. Like if a particular feature is misbehaving, or if you don't like the numbers that you're getting from analytics, you can just turn it off, or you can tweak it, or you can increase it. Like if it is a time-based feature, you can just turn on the time, say from 1 hour to 2 hours and so forth. Also, it gives you a better communication with your team. And one very important thing here is that always expose your dependencies. What I mean by that is if you have a short-lived branch, if a dependency changes for your particular code, you can always, because it's a short-lived branch, you can always reach to the parent branch and say, hey, oh, okay, I'm cutting. So the guy who changes a dependency, for example, we change, let's say, a work manager library from X, we have gone to Y. you don't have to worry about writing that code all over again or playing with those factors. Always try to reduce your risk. That is like risk mitigation. Always merge more often. If you have a parent branch, try and merge as soon as possible. Try and keep your commits short. Try and keep your code very well commented. So that when a person reviews your code, it's easy to kind of merge in without waiting a lot of those feedback loops with your review of your MR. So what will happen is that things will keep rolling. And also, as a good hygiene practice, please do a git cleanup every now and then, so you don't have branches lying around and being stale in the code base. Next, we come to something called as testing strategies, where we look at, first of all, when we say we create a feature for a production, we are creating a feature branch, and we have some Git branch naming conventions where we have something like a feature / ticket number / the name of the feature, or something like task / ticket number / whatever the name of the task that we're doing. A ticket number here, it could be something like a Jira ticket, or it could be some Trello or whatever else you use for project management. Next, try and break down your bigger task into smaller stories. The good thing is that you can also estimate your stories very well. When I say story, this is a terminology if you are familiar with Jira. If you have something like, let's build the next search for, let's put a search bar and let's get some search working for a particular screen. Can you break it down into smaller stories? Or can you do pointers particularly? Like, how many points will it take? Each point you can assume like it takes an hour, a day, or whatever, and try and estimate how much of your work will be needed. And try and also address for things like, hey, what if this is a dependency that I need and that is needed right now? So try and think of that. Also think outside the box. I know it's a very cliche thing to say, but the more you list down all your edge cases for a particular feature, the more easy for you it is to test at a later point, because you'll have everything detailed out in your ticket, and that ticket will become the wiki for you to kind of build that feature out. Also think about unit test and how you're going to do your test coverage. Even if you're not written code, always have a testing strategy in your head. Like, oh, okay, I'll have this dependency come in through DI and I will do this. And if I need an X output, I will put A or B and C. So try and think what are the other possible inputs that could lead to your results. Or also think of other results that could happen. Maybe the feature says we'll build search, but then the app crashes. So how do we tackle all those and so forth? So continuing with testing, we also love to say that tackle the fear. Fear here is like, what is the behavior of a particular code? Like, does it behave the way I want it? Or does it behave the way the business wants it, right? It could be a business logic. It could be even a dependency that doesn't behave. A classic example being, let's say you want to do something like periodically, a work manager, right? Does it execute exactly at the nth hour? No, it doesn't. So how do we tackle it? Can we write a test which checks, did it actually execute even if it is 2 minutes delayed? So how do we do all those? Try and avoid those fears. Like, be very vocal about all the dependencies that you have and how each of them work. Next, work around uncertainty of your code. Call it out. Literally call it out. Like, if you have some uncertain code, or if you're not sure how 2 and 2 works together, call it out. Maybe you have a peer who can help you out, and that way you can catch bugs before it even reaches production, right? Always try and avoid breaking in production. Like, do not regret a decision that you made. Let's say that you have built something a week back, and then you moved on to the next set of features. By the time this feature goes out live in production, you are now seeing hundreds of thousands, whatever your base users are. They start coming into an issue on certain devices or on certain behaviors of that flow, and you have no way to retract. So that's why also, if you remember from the previous slides, always have a feature toggle so they can control the flow for it. Also, bring some confidence into your code by writing unit tests. Also cover something like instrumentation. Try and do end-to-end if possible. That way you'll have a very good return of investment. Investment today that you do in your testing. Also, one point, when we say estimate your stories, like estimate a feature, we are keeping in mind that we are going to be writing unit tests for it. We're going to be doing some kind of a UI test for it. So we always estimate an extra day or two. Always be very choosy about how much time you will take to kind of deliver. Next, we have a very simple kind of test strategy that we always follow. We try and set up all the dependencies that we need for a particular component that we're testing. It could be a view model, it could be a presenter, it could be something like your repository, something that is going to have business logic, right? We try and set up all the dependencies. At Gojek, we use a lot of dependency injection. We use Dagger instead of like other things like Coin. So we already have the core in our mind, like, oh, okay, this is where I'm going to get the dependency A from, and this is where I'm going to get the dependency B from, and so forth. So we keep all this ready. We also think about how we're going to tear down. Like when test runs, always do a cleanup, not keep something in memory. Think of it like how does GC work or garbage collection works. Next, think of all the tests they're going to write. Like if you have one simple feature, like there's a search bar, you type on it, you should see results in a recycler view. What are the other edge cases? Like where's the data coming from? Can I fetch it from DB? Is it coming from an API and so forth? Like can you try and break it down and write success, the failures, the flakiness of it? Like what if there are 0 results? How do you handle that state? Think of all the states that your code will behave into. Next, we also kind of combine a lot of those into our test suites. Now, what we do this for is so that we can just hit run for a particular module. Like we have changed something. We also, in our PR process, we actually have to take a screenshot of all the tests that we have either inherently changed or externally. Like for example, there are 15 tests and I've gone and changed one state. So does the test work or not? That's on me. I have to make sure my code doesn't break what is existent. So try and build those suites so that when you run a test suite, you can actually come back and say, oh, okay, this is what is going to happen. This broke, and that's why I'll go fix it. And also, if you come across a lot of flaky tests, how do you address it? Like come up with a plan with your teammates. Try and solve tech debts as soon as possible. Don't keep a very long list of tech debts that last for over a year or so forth. Every now and then, try and pick something that is broken and try and fix it. Don't go overboard and always have that confidence with your test. Like if you change something, your test will kind of cover it. Also, if you don't have like real devices, like weigh the pros and cons, like how do you balance the act? If you do a lot of UI testing, do you want to run it on real devices? Do you want to use something like a test lab? Do you want to build an in-house solution and so forth? So there are a lot of things. At Gojek, we do a mix of both. At Gojek, we actually have a design framework, a library, which provides us components. And what this component does is we don't really have to do a lot of UI testing because the component behaves in a certain way. The states of that component is also behaved in a certain way. So we are very sure of what it's going to do. There's a dedicated team that writes those components and tests for it. We just go and integrate into our like particular screen, and then we start pushing it out, and we only test our business logic. So there's a lot of those backs, ones and zeros there. Also, make sure you are testing your performance. Like if you have 25 items in your recycler view, how well did it perform? Or, for example, like you're on create of your application, how much time did the code boot start? There are a lot of those tiny things that you could do to kind of improve the experience of the user. A user at this stage will not care about a lot of these things, but it's an annoyance factor, right? Like, for example, I don't use native Facebook Android app because it's freaking slow. It's not because it's super heavy. It's just because there are a lot of things that it's not optimized for, or rather, it's an experience that I don't have. I don't have a fun time with on, say, something like on my phone. So how can you improve that for a user? Maybe it's not asked for, but still why not perform for it? And also do some kind of security testing for your app. Like we always at Gojek, even though we have a lot of huge user base, both on consumer and driver side, and we have a lot of merchants onboarded and few tens and 20,000s and 30,000s of those numbers. We always do a security testing to see if our app is leaking any potential information. It could be very basic as your API endpoint, or it could be something like more complex, like someone is tampering with it, has a rooted phone, and how do we address those kind of things? Should the app work in a certain way? How do we debug it? Can we capture some telemetrics around this and try and figure out? With that, we come to another bit that we try to solve with Gojek, or we try and help our peers. So there's this word called burnout. A lot of people will not know what burnout is. Burnout is when you kind of just give up. You enjoy your work, and then you have that steep, and then you just crash down, right? You don't have a lot of fun after a while. So how do we avoid this? So few things that I want to kind of highlight here is avoid thinking everything at once. Try and be happy about what you have right now. If there's a large feature set that you have to build, try and break it into smaller chunks and try and target only that for a week. And don't pick too many things at once. Like try and do one thing at a time. So that your mind is focused on that, and then jump over to the next set. Once you're satisfied with one, then take the next on. And also adopt I wouldn't say if many people, like especially me, like I am pretty I have a lot of organizing thoughts in my mind. Like when I wake up early in the morning, I'm an early bird. I start at 8 in the morning. I check out from my office at 4:35. Once I'm out, I spend half an hour just to take a break, coffee break, stand on the balcony, whatnot. And then I start going back into my personal stuff. Next day, when I come back, I have mental notes of what I'm going to be doing. So always keep yourself prepared what you're going to be doing. Also, have a one-on-one with your lead. If you don't have a lead, talk to someone that you trust in your team, or you want to, even if you have friends, make more friends at your workplace. Like even though Gojek, we are all like working remotely right now, we do a lot of Zoom and Google Meet hangouts and stuff. And we also sometimes have a lot of one-on-ones, just chilling with your peers. And that way you can just burn some of those stress out. Maybe there's something that is blocking your thinking, and someone else has a suggestion for you, and maybe that works out for you. Also, one important thing, never regret your decision. When you do something, always remember be proud of what you do, right? And that is all about, that's where the happiness comes from. The work-life balance, a lot of those terminologies will kind of balance it out for you. A few things that you can adopt is ask yourself, do you want to kind of fall back of someone, or do you want to be in the background where no one notices you, or you want to be the leader, or do you want to be someone who people go to, like for asking a dumb question. Even if you have a dumb question, you can ask to your peer, or a peer can come and ask you. Always keep yourself up to date and try and build a good rapport with your peers. Also talk to a buddy. Like there's always something that you're going to learn. I have enough experience in this community and in this industry. I've been working as an Android engineer for almost 8+ years now. But there's so many things that I'm still so curious to learn. Like we have a lot of interns at Gojek. We have a lot of freshers that come to Gojek as well. There's so many things that these guys bring to the table that we probably as engineers will be like, oh, wait, why didn't I think of it? There are a lot of things that you could do. Also, ensure your physical health. That's very, very key important thing. And also keep your mental health. Like if you ever come across a situation where you're not happy with what you've done, and you feel that people are looking down at you, try and talk to your peers. Try and be open about it. Start a conversation with someone that you feel is doing something wrong about you, right? That way, at least you can throw your points out there into the people. If things don't work out, find something better and maybe switch a job or do something that makes you happy. Don't be too sad always in whatever you do. And always set aside a time to spike things. Spike over here is like try out new thing, maybe try out a new Jetpack Compose, spend some time for Flutter, or do something else that really you have never tried, and that way you will have some balance and that mental happiness as well. And invest wisely. Calculate your return of investment. Like read a book, maybe read something like a nice little algorithm book, or read a blog article, or write one if that is what is your game. And as always, for all Android devs out there, go play football, basketball, whatever when the Gradle builds. Just waiting and staring at that progress bar hitting indefinitely. That's no fun. Try and do something different. There are a few extra things that I want to just cover quickly. One of them is like definitely for all the Android devs who are just starting your career or are already pretty much in your career paths, working as an Android engineer, try and familiarize yourself with design principles, because even if you don't use it on a day-to-day basis, there are a lot of things that you can learn from a particular design. Like for example, like build a pattern. We almost use it every day, but if I throw that question at you for some random feature that we're building and we're in a hurdle, you can actually come up with a better idea, right? You can actually say, hey, what if you use something else, some other design principle, and that way we can solve this X and Y dependency, whatnot, right? Always familiarize yourself with these principles, and also take a deep dive into how the Android UI framework works. Because when you're building for a particular platform, it could be Flutter, it could be Compose, whatever you're using, right? React or whatever. Try and understand how that platform's UI rendering is kind of reaching to that point where it draws something on the screen. Try and understand that. That is where the core of the platform is. Try and see if you do something, how does it break? And if I do something else, how does it change, right? And in your spare time, if you have even 15, 20 minutes a day, try and build custom views. And I'm not talking like downloading a library and just dumping it. See what an open source library is all about. Maybe try and invest something. Maybe you built a custom library yourself. Unknowingly, you're using it in your production code. Try and see if you can write a blog article and try and take it into a smaller module and then ship it as a library. See what, like there's no one stopping you from doing that, right? Also try and play with your animations library, animations framework. There are loads and loads of things that you can do there. Also touch upon your the basics of Android, where how does a click work? How does long press work? How does the touch of, let's say if you have like a very small classic example, if you have a bottom sheet and you want to throw some other scrollable content inside it. So obviously the gesture of bottom sheet going up and down will interact with the other guy, the child view here. How do you interact? Like how do gestures work and so forth? Try and build a good mental picture of the entire Android API system and go one at a time. Don't take everything on yourself to learn. Try and do it over a week. Plan, schedule yourself, or organize this particularly. A few more things that I want to kind of highlight here is that understand the build process in and out. When you say that, hey, my build times are very pathetic, there's another engineer who solves it for me. It doesn't matter if you are part of a really great team where you have something like a DevOps team that manages the build process for you and measures metrics and then comes back and says, do this suggestion, do that. It's always nice to have that knowledge base with you. A lot of folks that I interact with, a lot of people that I've mentored, they come on and say, hey, Adit, I don't know how this works. Or rather, I just know that I hit Gradle run build and I do Gradle W build debug. I get something out. So try and invest some time there as well. Like what is actually happening? What are the Gradle tasks? Like, can I improvise? Especially with Android Studio 4.1 and above, you have those nice thing called build analyzer. You get time-based events of what each task took and so forth, right? And also know the impacts of your startup time. This will be really, really powerful if you can realize, if you can do lazy loading of some very heavy objects. You don't need it in the starting of your application. You only need it at the time of, say, screen number 3 in order, right? Screen 1 to 2 and then 3. So try and understand those and measure some bits of your application, like maybe networking. It could be a memory as well. It's nice to build something, but then also go back a step back and see if you can take a look at what those memories are. If you can't do this on production, you can always sidestep it and create a spike of your side project. Try and build something that is very complicated and see what happens. Like if I tweak this, doesn't improve. That way you're increasing your span of knowledge on the Android framework. Also optimize for offline usage, very, very important. If you have a particular flow where you have too many things to break, try and see if you can avoid network latencies and try and build an offline first approach if you've never built one. And try and work with large data sets. A lot of people only work on, say, something like no image, only text-based applications, or heavy image and no text, like semi-medium usage of text. So what happens with the balance? So try and break it and try and see how you can balance it out there. A few other things that I want to kind of put out there is always explore, write tests, break stuff so that you can learn from it, right? 4 very crucial, kind of completes the cycle for you. With that, that's it, folks. If you want to reach out to me, you can note down my website out there, aditlal.dev, or you can reach to that bit.ly link where you can schedule a small little 30-minute session with me and I'll connect with you. With that, thank you. Brijesh or someone out there. If there are any questions, I can take it now.
Yeah. Thank you, Adit, for a detailed talk. Like you covered a lot of areas from branching to pull request to Android-specific parts. It was really nice to know about the details of each verticals of what we do day-to-day basis. Folks, if you have any questions, just put out on YouTube comment, and I can highlight it here, and then Adit can answer those for you. We'll just wait for 2 minutes. There are no questions, and then we'll jump to the next talk. Even we had like a lot of new joinees in our team, and they came and solved. I think each one of them had one idea which we thought, why were you doing this for like 3 years? This whole like 10 steps, and it was just a one-line change. You could change it. Like they like not new joinees, like they bring a lot of new perspective. That's crazy.
Right. And I think the more you work with the larger team set, right, or even if you can interact with, you have a small team in production in your company and you interact with the community like this, I think that brings a lot of new points in your thinking as well. It's not just technical, it's also non-technical, right? Maybe someone does something better and you learn from it. Yeah.
Absolutely.
Cool.
I guess that's it, Adit. Thank you so much again. See you again soon with another talk.
Sure. Okay, guys, be safe.
Yeah. So for the next talk, we have Joe and Prateek from Buffer. Let me just add them to the stream. Hi, Joe. I'm not able to hear you.
Can you
Prateek?
hear me, Bridget?
Yeah, yours is fine. Joe, I couldn't hear you. Hi, Joe. Can you try checking your mic once? From here, it's on. We'll let him rejoin. So Prateek and Joe works at Buffer, and they are gonna walk us through today about how to start with declarative UI. So what we usually do is an imperative style of writing UI, and they will walk us through how to change that mindset and what is all this declarative UI paradigm that's coming up. So it's gonna be an exciting talk. Do you want to share the screen, Prateek? Meanwhile.
Joe has the slides, so
Okay.
I think he's joining. I'm seeing his screen right now.
Yeah. Just 5 minutes, folks. Joe is rejoining. We're saying some mic issues. Yeah. It's here. Hello. Yeah, it's fine, Joe. Yeah. Hello. It's very low for me. Your voice is coming out very low.
Is that okay? Is that any better?
Yeah. Yeah.
Cool.
No, perfect.
Cool.
Welcome back, Joe, to BL Android. We are very excited to have you and Prateek talk about the declarative UI.
Yeah, it's great to be here.
Nice. If you can share your screen, I'll just add it to the stream. We can get started.
Cool. So you should be able to see the slides.
Yes.
Cool. And Prateek, you can see the speaker notes on Zoom.
Yes, that's good.
Cool.
Yeah. Okay. Over to you both. I'll just remove myself from the stream.
Joe, I think you can start.
Are we live? I was just about to check.
Yeah.
Hey,
Yeah.
cool. Hey everyone. Thanks for being here today. I'm here with my friend Prateek, and we're here to talk about shifting from an imperative to declarative UI mindset. In this talk, we'll be kind of going through a high-level overview of declarative UI, learning exactly what it is and the ways in which we'll need to take a slightly different approach to thinking when working with such frameworks. But before we get started, we'd love to take a look at how things currently are and put things into a bit of perspective.
Cool. So in the 10 years or so since Android has existed, smartphones have evolved considerably in terms of their capabilities. And these capabilities have unlocked a lot of advanced and sophisticated use cases that we could not have imagined just a few years ago. With these capabilities, apps can do a lot more than they could before, and users' expectations from their apps have also increased. But if you look at the timeline of developer-centric announcements over the past decade since 1.0 was announced, we've had quite a few significant changes that have influenced the way in which we build our apps, Kotlin being one of the major ones. But if you look closely, we've not really had any major framework or tooling related changes that influence the way in which we build the front ends of our application. Recycler view, data binding, and constraint layout have assisted in the UI development process, but we are more like improvements that tried patching the rough edges of the current UI toolkit. So if we quickly take a look at the conventional way in which we would build a screen, not much has really changed on Android. We'll start by creating a fragment layout that houses our recycler view. Then we create a separate list item definition for our list items. And then we wire everything together in the fragment with an adapter. I sort of overly simplified the process by just using file names, but if you look at the amount of code one would write to scaffold something rather straightforward, in this case, just the fragment screen, it's clear that we are writing a lot of code. And turns out that this is not an Android-specific problem. Writing UI code conventionally has been very explicit and ceremonial. In this case, all I wanted to do was show a hello world text on the screen, and I needed about 20 lines to achieve it. Even if you eliminate the ceremonial pieces and look at the relevant bits here, this is still a lot of explicit step-by-step drawing instruction. It gets worse on iOS. And while it's uncommon for us to work directly with the storyboard's XML file, you might come across something like this when reviewing a PR. If you ever need to reference the backing code for a storyboard, you'll see how difficult it is to understand. And with complex layouts, this gets even more unmanageable. And in this case, in this obscure mess, we just had 2 lines of code, which is relevant to our intent. Writing UI code is also vaguely opinionated. So if you look at this screen, it can be built as a fragment with the usual view groups and widgets. But if you want to avoid the lifecycle hell, you can also build this out as a custom view entirely. So essentially, there's no clear indication around best practices. And if you want to come back to the screen and change the core structure, it will turn into a rewrite. The same goes for iOS. You can either build the screen using storyboards with Interface Builder or build it out in code completely. Whichever way you choose, it will be difficult, if not impossible, to come back later and switch the implementation out. Writing UI code is also separated by language. And what I mean by that is on Android, you write your layouts in XML with any backing styles and theming going into a separate styles file. The layout is then inflated by your activity or fragment, which is written in Kotlin. And then your UI is hydrated with data that comes from your view model or your presentation layer, which is also in Kotlin. So there's a lot of context switch involved. And if you've done Android for a while, you might have been conditioned into getting used to it. But people who are just starting out, they find it really confusing. On iOS, you build your layouts using Interface Builder, which generates an XML representation. And then the views are referenced in your view controller as IB outlets. And if there's any architecture in place, these views are then hydrated with data coming from the view model. The web is no different. You write your layouts in HTML, style it in CSS, and then flesh it out with actual data and logic from your JavaScript files. So every modern application uses some sort of architecture in place to reduce coupling, to make things more testable, and isolate related logic into its own layer. But these architectures have only helped us organize our business logic. When it comes to the presentation, we are not really doing anything radically different from what we used to do 4 or 5 years ago. And this is sort of where declarative UI frameworks come into picture. But before going into declarative UI frameworks, it would be beneficial to understand what declarative programming is all about. So declarative programming is a programming paradigm which focuses more on the structures of applications instead of the explicit, instead of specifying the logic and computation explicitly. And declarative UI frameworks sort of draw on the same idea by describing their flow and logic and letting the compiler figure everything else out on its own. So The three common declarative UI frameworks in use today are Swift UI, React, and Jetpack Compose, which is in alpha right now, but should hit stability sometime next year. So let's take a look at what it's like to build a UI using declarative UI frameworks. A core idea that these frameworks are built upon is breaking the screen down into smaller reusable components. And this concept was sort of pioneered by React. So this screen can be considered as a composition of the email list UI and the bottom app bar. The list UI is composed using an email card component, which in itself is built using 3 text components and an image component. So UI components are described as a composition of fundamental building blocks instead of the explicit drawing steps. So in this case, we have a vertical list of 3 text labels and a horizontal container that houses the list and the image. A regular model is then used to hydrate this component with actual data. And you can already see how easy this is on the eyes. So if you look at the implementation in Swift UI and Compose, here's what that would look like. So in both implementations, we have a row or an 8 stack that lays out items horizontally. We have a VStack or a column implementation that will lay out the 3 text items vertically. And then in both implementations, the fundamental elements are laid out in somewhat of similar fashion. And there are a few things worth appreciating here. First, this is a lot easier to read and reason about. And second, compared to the conventional approach, this is a lot less code that we are writing. Even if even if I include the code for actually building the list. And this is in stark contrast from a conventional recycle view implementation on Android or a table view implementation on iOS. We are also now focused on describing the UI instead of the explicit steps, which means that you get to iterate faster on your thoughts without getting slowed down by the ceremony. The code is also now in the same language as the rest of your project, meaning there's no more confusing context switch required. And the fundamental structure stays the same across different frameworks, minus some of the syntactic variations. This makes it much easier to understand code from another framework, even if you've not worked with that framework in the past. And it makes your skills a lot more transferable across these frameworks. But more importantly, the experience of working with these frameworks is truly game changer. So it's a lot of fun to write UIs this way. And once you try it, there's no way you'd go back.
So if we look around us in our field, we can see a clear shift towards declarative approaches. React has been in place for years. We've had a more recent solution for iOS in form of Swift UI become more prominent over the last few years. And now we have Jetpack Compose on Android, which has entered an alpha release. With these in place, there is a clear shift and also a need for something. But what is that and why? So let's take a look at some of these issues that we are currently experiencing with an imperative approach to building user interfaces. So in imperative UI, one of the concerns which can cause a lot of complexity is the coupling of our layouts and UI logic. In the case of Android, this is our activity or fragment and its layout file. So when we take a look at a current modern approach to building an application, we have our layout logic, the view model which controls the state of that screen, along with the layout file which depicts how that screen looks. The class which controls the logic of our screen will trigger actions in the view model to control its state, and the view model will pass back its state to trigger certain aspects of that screen. And this is fine, and this separation is actually really good. We have a single source of truth, and our activity is observing that. Now, when this state changes, the layout will change based on this. So the problem here is that now we are coupled to a completely different concern, and often a different language, which in the case of Android is XML. So here we not only need to verify that these dependencies are satisfied by the layout statically, but that they will be satisfied for the life of the program. And here we are telling our UI what it should be doing. We're not actually defining the UI of our app. This is where the issue is. Rather than just defining the UI at the point of observation, we take the result and then tell something else what it should be doing, thus increasing the concerns that are being communicated with. And this also increases the scope of change. To add or maintain one part of our project, we need to touch multiple points within it. In Android, we don't always have the guarantee that a reference we are accessing still exists. So finding a view by ID could end up in a null result, whilst we have the newer view binding library to help with view nullability. it is still the case that that reference may no longer exist. And just because something can be null, it can be easy for us to introduce bugs into our changes, especially if you're jumping into code that you did not originally write, which quite often is the case. Now, some UI frameworks have also been around for many years. Not that time is a problem, but when initially built, they were not built with today's constraints in mind, as Prateek mentioned earlier. And we have things such as support libraries on Android, and other frameworks have similar issues. So whilst we can eliminate XML and use custom views in our applications, we not only still have the similar responsibility issues outlined previously, but we're still working with the constraints of those legacy frameworks. Going back to support libraries, the Android UI toolkit is a good example of this. With imperative frameworks, we also see a greater level of complexity when it comes to the management of view state and how those views are constructed from states of the screen. So let's take another look at an example of a user interface. We have a single card component here that can be represented by several different states. We have a state where we're showing information for a lesson in my language learning app. The second item is when the user has favorited that lesson. And the third item represents a state where maybe something has gone wrong uploading that user's score. And if we look at the imperative style code that could be used to control this, we could end up with something that looks like on the right. And here you can see that we're having to check the different parts of the lesson object and then modify the view states based on those objects. So having to manually show and hide different views based on those states. And similar to Prateek's code example earlier, we can see that there's a lot of ceremony here and there's a lot of management we have to do. If we're making changes here, it could be really easy for us to miss out something especially if this part isn't covered by tests. Now, when it comes to something slightly different, we have no view modifications in place. We add components to the UI based on the lesson object. So when it comes to declarative UI, we don't need to, hide components. We don't need to say, oh, if this, then that, show this, hide that. Here we are essentially telling our UI, here's our data object, and here is what should be shown on screen. We don't need to worry about the previous state as such. And the key here is that we are defining what our UI is rather than manipulating it. This brings in a lot more predictability when it comes to the state of UI and reduces the chance of bugs within that user interface. And it's not just that the APIs from declarative UIs are nicer to work with, but the practices that they actually bring help us to write better code and build better applications. So from the previous example, we get a collection of improvements from declarative UI. Our apps can become more stable with the reduced changes and that single source of truth. We could be confident that our UI represents what we intend to display. And with this, things also become more maintainable, as if we are changing some part of code, we could be more confident that we are not interfering with some other piece. And this in turn makes things more testable because things are more predictable. Now, a big concept of declarative UIs is state and the way in which it is organized. But what is state? So all applications display some form of state. A few examples of state in Android applications could be maybe a switch that has been toggled on, a snack bar that shows some form of message on a screen, or even an item that is shown in a list, such as maybe a news article or the lesson from the example that we previously explored. And when it comes to the state in declarative UI, we begin to move away from unstructured state. And this is when we use view properties to manually change how a view is represented currently in Android. So with declarative UI, we begin to see the concept of unidirectional data flow. And this is essentially one-way data flow, which means the data has one and only one way to be transferred to other parts of the application. And in this concept, we have our app state, which is passed to the UI, and then the UI is updated to reflect our state. So with the removal of unstructured state and the need to manually assign individual view properties, we can utilize unidirectional data flow to have our UI built and then rebuilt whenever state changes. This works perfectly as we can ensure that all of our UI components are referencing the same piece of state. This causes them to be always up to date, and that way we don't need to individually worry about modifying UI components outside of that global screen state. Now, this is a high-level view, but what does this mean for our component trees? In declarative UI such as React or Compose, the aim is to pass our state from the top down. So our parent component will receive or hold some form of state, and then pass that data down through its children as required. If any of those children or components need to trigger events, they are passed up through the components, and that way the the parent component can then handle the state and the whole cycle will happen again. So the aim here is to pass state down and flow those events up. With these, we can already start to see the tie-in with unidirectional data flow. But when it comes to the concept of state, how does that actually map to the UI of our app? Within declarative UIs, our UI is represented by the functions that are used to render it. So the UI of our screen, or even its components, are represented by our UI functions, which take the state they should represent as their parameters. So when the state of our app changes, this triggers a redraw of the user interface. There is no imperative changing of the UI itself, such as view.setText. You change the state, and the UI rebuilds from scratch using the functions of the components and the required state. So let's take the screen as an example. We have an area of the screen which can consist of a list containing articles which the user can choose to read. When it comes to the state of this screen, we need to be thinking about the different scenarios that can occur or that the state we can be in. So is there a list of items? We want to show the list of items. Is the screen loading? And those items could also fail to load or be successful but not have any items to display to the user. These are all different states that could occur in different situations that we could end up in. With this in mind, we can construct our state based on these concepts. So our state object will consist of the items, whether or not the screen is currently loading, and whether or not there's been an error. So if our screen is loading, we're going to have the loading flag in our state object. We could also have a list of component, which would represent a list of items. And then also we could have an empty list of items. Or something could have gone wrong while fetching the data. In this case, we will show an error state. So here we have our state object, and that state object is being made up of those different values that represent that state overall. But how does this work? So remember on the previous slides, we talked about how we are declaring what the UI is, rather than modifying individual properties. So in this case, we are creating the UI components based on this state. We're not modifying any visibility properties or changing anything else related to existing components. We literally declare what the UI is based on that current state. This could look something like this, which would be called every time the state changes. So as our state changed, our content function would be called, the state would be provided, and then the different values of that state would be used to depict which UI component should be rendered on screen. So on the first run, we'd be likely loading the content, so that progress is displayed. And if successful, we want to show the list of items. So in this case, the UI would be re-rendered and a list would be shown. Now, because we haven't said that progress should be shown here, it would automatically be replaced from the previous state of the UI and not rendered in the component tree. So we covered the high-level state of the screen, but what happens a bit more into the component trees? So for example, the list itself is made up of child components. And in terms of a tree, this would look something like so. We have the parent node, which is the list itself, and then each of that list's children is represented by a child node. As well as the higher level component state management, we might also be curious about what happens lower down in those chains. So in the case of React, each item in a list is given a key, and this allows the identification of items that have been changed or removed, allowing individual children to be changed rather than having to re-render that whole list. So whenever some app components need to be updated, the state, it can do so using the update function. So for example, incrementing a counter after a user clicked a button or storing a server response from other components to render, calling update from anywhere in turn causes the entire application to re-render with that new state. And lower down those trees and in the logic, Prateek will be going more into this in depth later. Only the components that need to change will be updated so that things can be kept efficient. So for example, it might be the case that one of our titles in our news item changes. In this case, we're only going to want to update that first child. We don't want to re-render that whole list just because that one title was changed. So here, a node within that list has been changed. In this case, the compiler will detect this, know that that child with that specific ID or position has changed, and only update that child component. It could also be the case that we add another item to the list of news articles. Again, we're not going to want to re-render that whole list. Here, a child node would be added to our parent node, and again, the compiler would be able to identify that a new item has been added and render the update based on that. And finally, we may also want to remove an item from the list. As previously, the compiler would know that a specific item has been removed, re-rendering only the parent to let it know that the UI has been affected by that change.
Okay, so UIs are represented as trees with the container as the parent and other views as the nodes of the tree. When updating UI trees in the conventional way, a user input transforms and emits data, which is then consumed by the UI. And then through some tree traversal magic, a specific node gets updated. But when you look at how we update trees in the declarative way, user input transforms the backing state, which would be a state val in Swift, a React prop, or a composable function param. And this transformation emits a new tree entirely. Benefits of this approach is it's easier to read and debug, because now when you're debugging these functions, you always start fresh instead of assuming a previous state. Also, one implementation will cover all cases, which makes this concise and easy to understand. The trade-offs in this case are that it seems inefficient, and rightfully so, because you are recreating the entire UI instead of partially updating it. And that contradicts our understanding of drawing and performance. But if you look deeper, these are misconceptions rather than trade-offs. So imagine we lived in a world with infinite resources and no compute constraints. In such a world, recreating your UI from scratch won't be that bad an idea. In fact, in that case, tree mutations would feel like a lot of work in comparison. Our code bases would then look like a bunch of mapper functions that massage and transform data that your UI consumes. This means that our project shave off complexity by an order of magnitude. And the benefits here is that you would be writing less complex code and everything is super easy to follow. But in reality, that's not the case. And while we don't have infinite resources, we can still afford some trade-offs though. So declarative UI frameworks trade off performance slightly to offer the great developer experience and all the other advantages that Joe mentioned earlier, like a proper state management model and unidirectional data flow. The reason why these frameworks can do so is because they are optimized at the compiler level. So on surface, it seems like we are recreating our UI from scratch, but internally the tree is diffed and partially updated. This was pioneered by React with its virtual DOM model, where it compares the content of the virtual DOM with the actual one and updates only the nodes that were changed. So we no longer need to worry about overdraws and performance and have these nice abstractions to work with, while the framework does all the heavy lifting for us.
Sorry, I was trying to turn off the, I think someone said the preview's covering the slides, but I can't get my mouse to go to it. I don't think it matters too much now. Sorry about that. Cool. So a big question probably on a lot of people's minds is how can we get our apps ready? So Jetpack Compose is still some time away until it is production ready, but we can still start thinking about this stuff now. Whilst we're not going to go and suddenly refactor our whole app in Jetpack Compose as much as we probably want to, it can help to start thinking about the work we're doing leading up to then and how it can complement the approaches that will be used for declarative UI. And as a note, this isn't about doing things for the sake of it. These frameworks will not only help to bring us more stable apps, but a better developer productivity, and will also likely help with other things in our company, such as hiring and so on. As you know, if you know a company is like adopting the brand new things like Jetpack Compose, and you can work with that stuff, that becomes very appealing to developers looking for jobs. So a big thing here is about having a declarative mindset. So some of the things that we've talked about here and things you may read elsewhere, a lot of these are not specific to declarative UI, and they're things you can already do within your apps and other projects. To begin with, where does the state in your app currently live in the features and components that you're building? So start thinking about this when you're next building things or when you're maintaining things. We mentioned briefly about passing state down and flowing events up. The more of that we can start to achieve now, even bit by bit, and even if it's a slowly or zigzagging approach, the more we will have in place ready to support these frameworks when the time comes. And this naturally leads us back to unidirectional data flow. So this is something we are already doing at Buffett in our Android app and have been doing for some time now. And I know a lot of other companies and people who are doing so in their projects. As noted in the examples in this talk, Having that single source of truth that represents the state of your screen, that is perfect for Declarative UI and will really help with your transition to Jetpack Compose. You have the single source of truth, which represents the current UI state, regardless of whether you have Declarative UI or not. And that's already something you can start doing in your apps. And on that, because the Android view model and Jetpack Compose has great support for working together, utilize the view model in your applications if you can. If you're using the view model currently or are thinking about switching, it's great if you want to have a single source of truth, offload your state there and ensure that it's being used to handle any of the logic in your app. The more you can do here to have this in place, the smoother your transition will be when it comes to Jetpack Compose. And with this unidirectional data flow, this also gives you the opportunity to decouple your UI from the logic of your app. If you could do the work now to ensure that your UI components are free of logic around business and other state, as lightweight as they can be, when it comes to taking on Jetpack Compose, your task will be much smoother as it will become more or less a case of switching UI components out as you get the time to. With that said, that's everything we want to talk about today. Apologies for the Zoom preview being on the slides. We will post a link to the slides so you'll be able to view them afterwards. I think we've got a few minutes or so to take some questions if anyone wants to ask anything. We'll be happy to do our best to answer them.
Yeah, thank you so much, Joe and Prateek. There are a couple of questions. I'll start adding those to us too. Yeah. So Adit is asking, how does one measure performance of such frameworks? There are some tools out there and provide this.
Sorry, I think you cut out there. Would you have to repeat the question?
Yeah, are you able to see it on the screen? Yeah, so it's asking, how does one measure the performance of such frameworks and tools for Declarative UI?
That's a good question. As far as I know, oh, there you go, I can see the question now. In terms of Android, I haven't actually tried using any of the built-in tools within Android Studio for doing app performance measurements or monitoring. You probably could use that and do a kind of comparison. I'd be interested to know if Google are going to do anything there along measuring Compose-specific stuff. But yeah, I don't think, as far as I'm aware, I don't think too much has been done there or explored there in the community just yet. I'm not sure if Prateek knows any more on that than I do, but yeah, other than the current tools that are available, I don't think there's anything special for doing so.
Yep, same thoughts there. I don't think, I mean, like, we can assume that when Compose becomes stable, it will be comparable in performance to the current UI toolkit. So ideally, the same tools that we use right now to profile the performance of our apps, they should pretty much carry over.
Yeah.
Nice. Okay.
But what would be cool, just to add to that, like if you do use performance tools currently, it would be cool, and I think people would really benefit from you measuring your app performance now, and then later measuring it when you do have Compose and sharing that information, because I think that would really help people to, you know, make that shift and could help within companies as well.
Yeah, that would help us in figuring out in multiple cases, like for different app, what happens when they want to declare. Great. Any other questions, anyone? You can post it on YouTube channel.
How long till Compose comes stable?
Yeah, this.
We should start betting on this.
Yeah.
My guess is summer next year, but I know I was talking to someone about this the other day, and with everything happening at the moment, like people not being in the office and maybe people adjusting to remote work, anything could happen. It could get pushed back whenever it might be. I'm guessing at least summer, maybe more towards the autumn, but depends how the developer previews play out, I guess.
Yeah.
2021.
Yeah,
I'm hoping so. Who knows though? Yeah. I think like the more people, like I know a lot of people are playing with it. But I think the more people that give feedback and report bugs they come across, like this, that will really help. So if you do find issues, like do report them, and it is worthwhile doing so.
Yeah, it will be faster if we play with it now and then give it back.
Yeah.
Great, Joe and Prateek. Thank you so much for the talk. I think that's it for the question side for now.
Yes. Yeah.
Cool.
Cool.
Yeah.
Thanks for having us.
Yeah, thanks for having us. Like I said, we'll put the slides online so people can see them. Yeah, thanks again.
Yeah, bye.
Cool. See you later.
Yeah, bye. Hello everyone. So I hope that was useful to get a bit to know about like what is declarative UI and how the UI framework the future will change once Compose is here. For the next talk, we have Sowmya. She is let me add her to the stream. Hi Sowmya. You're on mute. So if you can unmute. Sowmya, can you hear me? Just a second. Hello. Yes, Sowmya, if you can hear me, can you unmute yourself so that we can get started with this? Okay. She's figuring out mic. Just few seconds, people. We're just setting up. She's just setting up her mic. Okay, it was on mute for a second.
Yeah.
Great. Yeah, Sowmya. I think it's for the question side for now. You don't see your YouTube, guys.
Yeah. Yeah, thanks for having us. Like I said, we'll put the slides online so people can see them. Yeah.
Yes, yeah, Sowmya, can you turn off your YouTube? Because that's a 10-second delay. It will delay the voice. Hello everyone. So I hope that was useful to get a bit to know about like what is declarative UI and how the UI framework the future will change once Compose is here. For the next talk, we have Sowmya. Can you come to StreamYard and just turn off the YouTube stream? Hi Sowmya.
Hello. Hi. Yeah, I'm just trying that. How does it look now?
The slides are here. Can you turn off the YouTube stream?
Yeah.
Yeah, cool. Now we are set. Okay. Sorry, everyone. So we have Sowmya here from Berlin. She is a freelancing Android developer, and she's gonna walk us through today about pair programming. Let me add your slides to the screen. Yeah, Sowmya, you can get started. A bit intro about yourself so everybody knows, and then you can get started with the slides.
Sure. So, hello everyone. My name is Sowmya, and I have been working in Android for more than 7 years now. And Bangalore Droid community is quite special for me because it's Bangalore is my hometown. And for the first time, I joined BLR Droid community in 2012, I think. And I've learned so much from these folks, and I'm quite happy that I got this opportunity to speak to you all again. And yeah, these days I'm in Berlin, and I've been in Berlin for more than 6 years. And yeah, I'm working in freelance now, and also founder at Coder, which is a small coding school I started as a part of the community when women wanted to learn to code and co-learn. And yeah, ever since 3 years, I've been doing this as a part of Coder. And if you want to yeah, keep a track of what I do, you can also follow me at Just a Bad Robot on Twitter. And just to get started with this topic, I have to mention that pair programming is one of the topics that has been very special for me because I'm quite inquisitive to learn new things, and pair programming has helped me a lot in this area to bounce off ideas, exchange knowledge, and things like that. And I'm pretty sure you all know how important it is as a programmer to keep in touch with latest technology and to be up to date with what's happening around you. And for sure, pair programming is one of the things that help me learn new concepts from other devs. And ever since I have started pairing, I found inspiration to actually do Android, to continue in this area. So that's why this talk, because I've been doing also some research on this area, and I realized not many people have been pairing quite as much, and it could be quite daunting initially when you start to pair, even for like seniors, juniors, any level of programmers. But I can assure you, once you start to pair, you would never want to go back. And it's always fun to do things together. And something like programming could always be fun with other devs to work collaboratively. So according to some stats I collected, it was quite evident that not many devs like to pair program, and not many companies also push for this concept, which is an agile concept. But let's talk about it and see if I can convince you to actually start to pair program. So just to give you a bit of history, pair programming was first actually not unofficially, but yeah, it started with in the 1940s by ENIAC women who actually were 6 programmers, and one of the programmers, John Bartek, said in one of her interviews that Betty Snyder and I from the beginning were a pair, and I believe that the best programs and designs are done by pairs because you can criticize each other, find each other's errors, and use the best ideas. And this was in the early 90s. And you can imagine this was a concept. Of course, it was not agile concept until later in the 1950s, but this was still a recognized concept. And they found even in the early 40s that this was very important to have extra pair of eyes to look at your code. And 50 years later, there was a book called Extreme Programming Explained, where for the first time, pair programming was mentioned by Kent Beck, and it became kind of which put pair programming on the map. So ever since, let's just understand what is pairing or pair programming. It's just 2 programmers sitting and writing code together and working on one piece of a program. And there are, like I said, many qualms about this concept, and it could be coming from different places, I would say, for different developers. Might be you had bad experiences with certain people pairing, or maybe you did not even try this concept. But definitely sitting with somebody in the same room and with somebody breathing down your neck would be quite hard for me as well initially, when I realized that I have to pair program. And it kind of gave me butterflies when I actually started thinking about this every day, until a few days, of course. And yeah, that's why this little comic about Scott Adams, but you can take a look at that later. So pair programming, I want to say that it is a soft skill that can be learned, and it can be improved with time. And let's see what are some of the qualities that are required for this, because we always talk about a lot of things that we learn and how we learn, how we manage time and be productive, etc., etc. But there are certain qualities and mindset that is also important when we try to collaborate and work as a pair. So definitely cogent communication helps, and some of the other qualities, like being open to ideas and changes and not having like something that is set on stone, and being flexible and curious could be very helpful. Being empathetic towards another developer and thinking that this person is just trying their best, and understanding where they're coming from and their backgrounds, which is also another good thing, that you know your colleagues. That helps in actually building a rapport and to be empathetic. And some of the things like being patient and not hurrying people is really great. Being honest about what you know, what you don't know, having the growth mindset to learn, to actually believe that you're on this together, you're in this together, and you have to get stuff done. That is more important, right? So yeah, some of the other qualities, like being courteous, having good manners, saying please, thank you, being polite, placing your trust in the other person, and believing that they're doing their best is another good thing. So I would say this is more of a mentality to keep an open mindset and to hear somebody out, to exchange ideas. The end goal should be getting stuff done, and communicating easily and more effectively will actually help you learn and grow as well. So let's talk a little bit about how pair programming can help you in your journey from going from being unconsciously incompetent to conscious competence. So this is might be a bit confusing, but just bear with me here. What I mean is, unconscious incompetence is not knowing what you don't know. And that is the majority of all of us. Maybe 99% of the things in the world we don't know that they exist, or yeah, we don't know about them. So that is called unconscious incompetence. And unconscious competence is, you somehow know it, you get this gut feeling, it comes from somewhere, but you don't know where it is coming from. And that is unconscious competence. And unconscious incompetence is, you know that you don't know something. And this is a good state to be in. That means that you know that, say, Jetpack Compose exists, but you don't know how to implement it. So you have to just go there, look at the docs, talk to people, and implement it. So you already know what you don't know. This is a good state, and this is where we want to get at. And conscious competence is actually knowing what you're doing. And that is when you can actually sit with a person, and when you talk about things, your pair can actually help you get there. Imagine you had no idea something exists, to going to knowing something, sitting with somebody and writing that part of code. You can go from unconscious incompetence to conscious competence in quite very little short span of time. And that's why I say this is a journey, and you can go through this journey pretty quickly if you have a pair. And some of the common ways of pair programming is, of course, solo, and the rest are, these days remote is quite popular. And you could actually pair program remotely, and also mock program remotely if you wanted. Sorry, yeah. Mock programming is basically everybody or many people in the team get together and solve a piece of program or code, or even come up with some architectural design changes, which requires bigger decisions. Let's talk a little bit about why we have to pair program. There are few common myths that are involving pair programming. So some of the myths I hear and also people talk about in the community are it increases development time and costs. And it might seem like it does increase development time, but we'll talk about the benefits a bit later. There are people who say parallelizing work speeds up delivery. That means one person delivering one piece of code is much faster than two people working on the same piece of code, which I would also debunk this myth a bit later. And pairing should be optional based on personality types. And this is something I heard myself and also other people talk about. Some people resist to pair programming because they're not comfortable writing code when somebody's watching. So managers say, okay, leave them be. It's not their personality. They're introverts or extroverts. It doesn't depend on that. Developers get lost in the rabbit hole. So when two people are sitting and you start discussing, and then you start arguing about something, and it's easy to get lost in the rabbit hole. This is something I've heard as well. But looking at the advantages, we can definitely agree this is not a big problem. And it has developer productivity. This is something also based on parallelizing work. It means if two people working on the same piece of code might have the developer productivity. But for this, Martin Fowler, who's also an advocate of pair programming, writes that it would be true if the hardest part of programming was typing. So I do agree with this. Pair programming is not just about typing. It's a way more, and we'll see what are its benefits. There are two major problems I see during pair programming. Why people or companies do not support this concept that much is because they cannot actually tell or quantify the productivity or effectiveness of this concept itself. And it's really hard to quantify this, to collect data and to say, okay, these developers worked on these things for this period of time on this project, and then they produced so much and they were so much of cost benefits. So it's really hard to actually come up with metrics for these. And that's why people are not convinced that they have to implement pair programming or push programmers to go in this direction. And also, it's definitely not easily implementable. Mostly, like I said, developers might have their own qualms about these concepts, maybe bad practices coming from bad experiences. And it's not easily, like, people would accept this when somebody says, let's just start pair programming from tomorrow, right? So to know, if you know the benefits of pair programming as developers, if you can yourself push, because it's easy to get stuff done, but two people sitting at a workstation for an hour than one person going on the internet, researching and getting lost in the ocean of the wiki of knowledge. So definitely, it's not easily implementable if you're not willing to try this. And that's why I'm here to tell you why you should try this. Hopefully, you'll be convinced at the end. So why should we pair program? So one of the studies shows that pair programming produces 15% fewer defects in code, which is produced by pairs as compared to single solo programmers. It improves overall code quality, mostly because as and when you're writing code, you're reviewing the code. Somebody else is reviewing the code, of course. And it's easy to catch bugs way early during development than later. So it's definitely, sooner is better than later. That means, imagine you're issuing a pull request and somebody is reviewing your code. They see it's a big request and they start reviewing. First of all, it takes a lot of effort to review. And secondly, you've already written the code. So the developers, even if they know that in their hearts that this is probably not a better approach, or there could be a better approach, maybe sometimes it's easy to give way for sunk cost fallacy and be like, okay, this is already done now, let's not just go back and rewrite this. So sometimes it's better to review code. I mean, most times it's better to review code way early in development rather than later. And this also reduces a lot of rework for the developer and accumulation of technical debts, which is one of the biggest traps in software engineering, as we all know. And another benefit is focused. It keeps you focused. When there are two people involved, definitely you don't let each other get distracted easily or lose focus. And that's why it helps you get more stuff done in short period of time. And definitely an added benefit that I found is that when two people are sitting at a desk and trying to do something, people don't want to interrupt you. And that also helps you to avoid distractions. It improves your skill set and helps knowledge sharing in the team. And it also helps in getting better understanding of the code for everyone in the team. So if you're pairing and you're rotating with other developers while pairing, that is highly recommended, of course. You learn new things, and not only that, you learn all parts of code that's written by this pair, or even you both sit together and learn the part of code in the code base. That means that it improves your overall knowledge of the code base very quickly. And this also means if you're onboarding on a new project, it's much easier to just ask questions and get onboarded than look in the code. So this reduces actually also a key person index, what we call, which means that one person being the hero of the team or shiro of the team, and the rest of them have to rely on this person for the knowledge, right? So this key person risk can be reduced when there is bouncing of ideas and regular pair programming sessions. That means that in a more colloquial manner, if a person gets hit by a bus, or your hero gets hit by a bus, then all the knowledge is lost. Or rather, let's say somebody in your team wins a lottery and stops coming to work, and then you don't know what to do. So that is key person risk, and to reduce that, pair programming is a very effective tool. And helps in continuous integration, of course. And most importantly, I want to stress upon the benefits of how it improves collective ownership. It produces this sense of accomplishment, and it brings satisfaction in the team, especially when you know that you've built something together as a whole team, or even with another person, and you've achieved this goal during the day. And at the end of the day, it feels so good. It's so much more fun to do it with somebody and share this happiness. So mostly I would say it's fun, and that's why I do it. Hopefully you can also figure this out for yourselves. And coming to the last part of how to pair program. Firstly, I always recommend people to focus and review your setup, because you don't want to be distracted by, your hand kind of aching because of your not having a good ergonomic mouse, or proper setup with a different height or a chair and things like that. So get your setup in place, and make sure that your setup is always the best, so it doesn't distract you from what you're trying to do. And for pairs, of course, in real time, I would recommend one computer, two monitors, 2 mice, and 2 keyboards. But in a remote setup, it might be more than that. So have 2 computers. Of course, you will have 2 computers, have 2 mice and these kind of things, but also have other apps and tools that will help you remote desktop sharing, messaging, ideating using Jamboards, and proper video conferencing, audio conferencing, and things like that. And coming to the roles of pairs. So there are 2 different roles a pair can be in. So one is navigator, who is actually providing a bird's eye view of direction of work, which means they're in the tactical mode, and they'll be talking about what is the next step. We'll sit down with a notepad and write down stuff, and tell you, guide you as to like what needs to be done next. Or for the piece of code you've written, they can review and tell you what could be improved and things like that. And driver is a person who literally sits on the keyboard and starts to type code. And they're in the mechanical mode, which is why they're mostly focused on the syntax of the code and the language and things like that. So it's hard to actually think ahead in time, which is why it takes time to, it takes a bit of time to refactor once you've already written some code. And that's what navigator will jump in and tell you, like, okay, already we can write it this way. So yeah, these are the 2 different roles. But of course, it's important to keep changing roles, and no one person should be in the same role for too long. And that brings us to the necessary techniques that are there that you could make use of while pairing. And one of them is a ping pong method, where it is a pair rotation technique. And that is when you do more of TDD, one person can write code tests and the other person can switch roles and start to write code. This is called a ping pong method. And have a task list and write down the tasks, subtasks, what is to be done. And this is another way to keep in track of what needs to be done. And definitely Pomodoro technique is a great way to switch pairs. For instance, you can do Pomodoro for in bursts of 20 minutes, 45 minutes, 1 hour, whatever works for you. Just have a timer, start the timer, and do not go beyond this time, and try to stop when the timer hits the time. Definitely, whether you complete or no, that's a different question. Just stop at the time. And I also recommend people to have pairing templates. So what I mean is, usually I have guidelines. So say you're working on a project and there are a couple of developers, and you might have guidelines for how certain things to be named and how certain things, what kind of frameworks you use, what test cases you write, how they should look like, how they should be named. So all these kind of guidelines should be, in my opinion, in a wiki where everybody can look up. So whenever there is a conflict or a dispute, then you can immediately use that as a source of truth and come up with a good logical argument. And definitely use comfortable tools. Pick a task, especially if you're a newbie, pick a task that is super easy to code and you already know what should be the outcome. Find a personable developer who you know in the team, ask them and request to sit with you and code for a couple of hours. And I'm pretty sure people are nice and will be easy on you. And take breaks as much as possible. Definitely do not get into this flow and not take breaks for sure. As and when the Pomodoro timer hits your time, just stop and take a break, walk around, do whatever it is that you do and come back. Also, attribution is a very important thing that when you come when it comes to pair programming, because most of the Git tools do not let you attribute correctly while you're pairing. So it's important to actually use some tool like Git Duet to actually show what is done during pair programming. I do recommend you to go check it out. And lastly, do have a mini retro and talk about your achievements. So a mini retro is just, you just say what went well and what went wrong, and you just try to improve what could be done. So just say, for instance, that somebody was hurrying you while you couldn't think because this person was impatient. You could just say that at the mini retro and be like, it would be helpful if I could get enough time to write this, and or you could start to speak after I finish writing this line of code. So come up with something that works for you and your pair, because definitely you have to communicate what is acceptable and unacceptable to you. And mini retro is that way. That is, it gives you the platform to actually put forth your concerns, and also appreciate people when they're being proactive, or some people leave really cool comments on your say PRs and things like that. So do appreciate them and be grateful for it. And just agree and accept that it's okay to be nervous. And everybody is nervous initially when somebody is trying to sit with you and look at your work. When it's hard to be creative when somebody is actually sitting with you and to collaborate and write something. It feels like, your head is cluttered and you cannot think clearly and things like that. But that's only because you're nervous probably, or you're not used to this. But once you get used to this, for sure, it'll get much easier. And it'll be very rewarding, I can assure you this. So just breathe, take a deep breath. Not everything is fine. Just give it a shot and see how things go. And if it doesn't work, for sure, say, let me just do this by myself and get back to you. So you don't have to also continue if you don't feel comfortable. That is also fine. And remember that this concept requires intense collaboration and deep work, and which is why it is quite a lot of emotional labor, and it's quite a lot to ask from someone. First of all, programming could be quite challenging, but imagine you have to speak out and communicate, and it's a lot of things going on there, right? So that's why it's more important to take breaks and not keep doing this for long hours in a day. And as I said, it's quite a lot of emotional labor, which can actually cause a lot of distress or discomfort. It might sometimes feel like imposition when you don't want to do this, and somebody else says, no, we have to, this is a rule in our team or something like that. And it can cause exhaustion if you're sitting for long hours. It can bring friction in the team because of not proper communication and things like that. So definitely it's, like I said, a lot to ask. But if you get to a sweet spot where you can code effectively with your partner, then it becomes way, way easier. And that brings us to this point where what not to do and to avoid. And these are a few things that's natural. As human, we always tend to lose interest or focus. So drifting apart is one of the ways you start looking at your phone, or you get distracted easily. So try to remove distractions when you know that you find it hard to focus. I also recommend meditation if you find that focusing is hard for you. And do not get into this mode of micromanagement, which means that some people start telling you they start to dictate things than to instruct. So instruction is, can we try writing the say method for something to do this? And dictating is, can you please write system.print. You know what I mean. So just don't get into the micromanagement mode, and try to be patient with your pair, And do not try to hog keyboards. For instance, some people don't feel like they're being productive if they don't type on the keyboard, and that is not true. That's why we have pair rotation methods to rotate pairs. So it's important to also look at things in a bigger picture and not just keep mechanically typing on the keyboard. So of course, programming is way more than that. Avoid pairing for 8 hours a day just because you like it or whatever it is. For sure, it can cause exhaustion. So avoid pairing for long hours, and do not work without taking breaks. Also, I would recommend you to have some sessions like 15 minutes of meditation or half an hour of running. These kind of things, breathing, dancing, whatever floats your boat, just do that in your breaks. It is also, studies show that it makes you very creative, and it helps you come up with better ideas when you take breaks. So it is basically your brain is working in two modes. One is diffuse mode when you're distracted, say, and another is focus mode. That is when you're completely focused and you're in a flow. Say you're getting into something, writing program, and you're lost in this flow for hours, right? So it is important to switch between these two modes. And when you take breaks, that's when your brain gets to relax and come up with better ideas when you come back to this activity again. So whenever you're stuck or something, definitely try this. Maybe it might be helpful to find a new perspective. And just remember that there is no silver bullet for any pair. So if you have problems, speak up and talk to your pair about it. Ask them for coffee, do whatever it is that you do. Just talk to them and ask for a one-on-one and be like, let's talk about how we pair, or do it in a mini retro and tell them things what did not go well for you and what could be improved. Rather, provide constructive feedback. So how to be a good pair? Firstly, be focused, discuss things, understand where your pair is coming from, or try to ask good questions. Care for your pair whenever they want to take break. They might be some days unmotivated, whatever it is, it's okay. Sometimes it's okay to be just a rubber duck and be unmotivated. It's not that every day you'll be super motivated about things. So be caring. If they're undergoing something in their lives, be understanding about it, and be sharing. It's okay to share whatever, how you're feeling, or about the weather, whatever it is that makes you comfortable. And always trust your pair, and remember that they're trying to do their best. So have the trust, and yeah, it's all about working together as a pair. And how a successful pairing session looks like. First, agree on a high-level goal. Then break down this. This could be like, say, a ticket somewhere, like on Jira or something. And break down this task into, if possible, into much smaller subtasks, or prioritize whichever you want to do first, whichever is easy, whatever works for you again. And decide on techniques, how you do this. If you're starting with a new pair, then tell them how you do this and ask them about their ideas, how they pair, and come to a good common ground on this. And of course, configure your Git to share credit. Always give credit to people who have come up with this. Eliminate distractions, keep your phone away, whatever that is distracting you, keep it away. Take breaks, end with a mini retro. And that is kind of a good pair programming session, in my opinion. And yeah, mini retros are one of my favorite part, because you get to talk about what could be improved, and talk about your achievements. So having a donut is basically celebrating your milestone and appreciating the good day's work you put in and your pair have put in. So give them also appreciative kind of greetings, be thankful for it. And it goes a long way in building team morale, for sure. And when are you an effective pair? So these are just the qualities that can make you a good pair. Think out loud. Just keeping quiet will not help. So the other person is not a mind reader. They can only hear you because they're also typing probably. So just think out loud, articulate it in the best manner, and listen carefully and make suggestions. Do not make remarks. Do not say things like, "Oh, that's a stupid thing to do," or "That's a stupid solution." Don't make remarks, but always come up with constructive feedback, and don't show your frustration or don't attack the person. Don't get personal, and don't launch an ad hominem attack on them. Just give constructive feedbacks as much as possible. And prioritize your learning over productivity while pairing, especially with juniors, because it might seem like, oh, they're going to take up our time, but it's important to bring them to a good level. And for sure, if you articulate these things, it's also the best way to learn by mentoring people. So definitely learning by mentoring is also another way to be very productive. It clarifies things in your head, and it's really hard to articulate things like complex concepts in simple manner, which is why it can improve your personality and your skills as well. And respect personal space. This is another thing that sometimes you find people with, bad breath by not showering, or it's possible, you don't know about others' personal hygiene. So always when you're pairing, make sure you maintain distance, you pop a gum or whatever it works. Just don't make other people feel uncomfortable or cause any discomfort in them. So, and maybe they don't want to pair with you anymore. So yeah, try to respect somebody's personal space. And if they want to take a break, go for coffee, and they have had enough, for sure. I mean, even if it's not, if you're in between flows, it's fine. If somebody wants to do something else, just go for a game of ping pong, right? And at the end of the day, as I said, this whole process is quite taxing, and just be understanding, be trusting, be human, be vulnerable, and everything that can help you be productive, work as a team, and have a high team morale. So it could actually bring a great sense of accomplishment if you do this in a way that helps you and your team. And that's pretty much all I had to say today. And I want to give some credits to people who actually inspired me to give this talk. And that's Sowmya, one of the persons from Berlin community. And she is a backend engineer, and she gave a talk which inspired me to give this talk. And I've done a lot of research where ThoughtWorks has been one of the companies which kind of emphasizes on this topic a lot. And they pair quite a lot as far as I've heard. And these are some links as well for you to check out. And I also got inspired to write some stuff about pairing. My initial inspirations that came from my fellow developers when I started a company in 2013 or something. So yeah, and also about how anybody could pair program and how you could improve those tactics. Everything that I spoke today also has been written down somehow in these few blogs. So do check them out if you're interested in this topic. And that's pretty much it. Thank you very much for coming to my talk on a Saturday. And yeah, I'm quite happy that I got this opportunity to speak. Thanks a lot, Wheeler Droid, and everybody else is involved.
Thank you so much, Sowmya. There was like a very detailed explanation of multiple techniques and tips and tricks, to make sure you're not getting burnout and you're respecting each other. A very well thought explanation of pair programming. If anybody has questions, you can put it out on YouTube comments, and we can take it up. Sowmya can answer those. So So one of the question, I'll highlight it on the screen, Sowmya, for you. Are you able to see it?
Yeah.
Yeah. So Nimish is asking, are there any particular type of problem we should, take up when doing pair programming, or does all kind of problems are fine to take up in a pair programming session?
Yeah, like I said already, that pick an easy task, and if you're used to this already, if you're a pair programmer already, then every problem could be taken up as a pair programming task. I also do sometimes documentation while pairing with other programmers. So there is no task that says that you shouldn't pair program. There's always an extra set of files that could be helpful while doing something, right? So if it brings value to both of you, definitely go for it. And if you think it's not that important, say you're fixing a bug which is related to a text view, and you know what to do, both of you know what to do, and you just have to push it, then I don't see what that won't help you much, right?
Yeah.
So definitely go with something that is a little bit challenging, or that would take a lot of mental power for you to do it alone, for sure. I would recommend those cases, but everything could be done with a pair. It just depends on what is important for you too.
Yeah, got it. That explains it. Uh, Great. I don't think we have much questions as of now.
Okay,
Uh,
that's
yeah,
great.
we'll share. We'll get the slides from Sowmya and we'll share it so you can go through it again and all the references that she has mentioned.
Yeah, thank you very much for having
Thank
me.
you.
And yeah, it was great to be here again. And yeah, British and the whole team of the Droid have been doing great. So yeah, looking forward for more. Thank you.
Sure, sure. We'll glad to have you back on Beard Right. Thank you so much for taking our time.
Thank you. Bye.
Oh, yeah. Bye. That's it, everyone, for today. Hope you had a good meetup and all the talks were useful. Please do share your feedback. I'll send out a email with all the slide notes and all the feedback forms, so you can tell us what you want to see next and what you want to improve. That's it from today. Uh, Please be safe, wear a mask, and take care of your health. Signing off.